All right, good morning. So we're going to take a look at taking our probability discussion just a little further and take a look at this concept of, is something dependent upon what happened or is it independent? Now, a lot of this you guys have already dealt with as far as independent, dependent variables, things like that. So we're going to take a look at just a few examples here, just so we're clear on what independent and dependent actually counts as. So, for instance, does the weather outside, sorry, let me rephrase that. Does what you wear to go outside depend on the weather? So are they dependent events or are they independent events? Take 3 seconds, decide which column you're going to put it under, ready, go. And I think it would be here. So clothes and weather definitely would be dependent events, right? Your clothing depends on the weather. If it's raining, if it's cold, hot, sunny, etc. Okay. Now let's start talking about probability. I mean, you could go through all sorts of stuff, dependent, independent. So let's start focusing on probability. If I flip a coin and then I flip the coin again, does the second flip really have anything to do with the first flip? Okay. Decide 30 seconds, where does it go? Coin, dependent, independent, 2 flips. The answer is it is independent. The second flip really doesn't care what the first flip did. All right, what about a dice or a die? So I'm going to roll a die. I'm going to roll it 2 times. Does the second roll depend upon what the first roll was? 3 seconds, go ahead, put it somewhere, pick a column, dependent, independent. And the answer is no, it doesn't. All right, dice are independent events because it does not matter what the first one was. Okay, so here becomes the kicker, I think. Tiles, colored tiles in a jar, and you're going to draw them. All right, you're going to do 2 drawings. You're going to draw, you're going to put it back like we've always done in class, and then you're going to draw again. Does the second time you pull something out depend on what you drew the first time? 3 seconds, where do you go? Dependent, independent. The answer is over here. So if you draw, and what it's called is with replacement, which is what we've been doing the whole time. Every time we've drawn winners in class, we have been putting the item back in. Okay, so for example, you have a container. All right, in there you have 3 blue and 2 red, right? You draw, take a tile out, but what we've been doing is then putting it right back in. So every time you draw, you have 3 blue and 2 red to pull from. The difference now is this. I'm just going to put it over here. Draw without replacing. So what does that mean? Same bucket, 3 blue, 2 red. This time when you draw one out, you don't put it back in. So what does that mean? Well, how many tiles do I have total the first time? I have 3 blue, 2 red, gives me a total of 5. If you don't put that first one back, you take it out and leave it off to the side, how many do you now have left to pull from? Well, the answer is you only have 4 left to pull from. So what that means is, and we're going to get to examples here in a second, you have to understand that if you are not replacing, your bottom number is going to change. All right, I have left less to pull from. All right, so let's take a look at some specific examples and we'll go from there. All right, so here in IXL, I lost my spot. Give me a second. There we go. There we go. So in IXL, here's an example. I have 4 cards I'm pulling from. And notice in the wording, I'm going to pick a card and then without putting it back. So know ahead of time, because I'm not putting it back, my number is going to change. Now, we're going to take these couple ideas we've done together here. So One is this idea of dependent, independent, but the other is what happens when you're doing a couple things. Remember, yes, last week we stacked items, so you take your probabilities and you end up multiplying them together. So in this question, it says, what's a chance of picking a 3? So essentially, it looks like this. What's the chance of a 3 and then a 3? So under my first probability, what's the chance of a 3? Well, I have 4 cards and I have 1 3. So I would put in 1 out of 4. Okay. Next up, my next one, I did not put the card back. So what is now my chance of picking a 3? And here's the hard part, is what you have to understand. In order for this whole circumstance, this whole setup to be a win for us, both must be true. Because guess what? If I didn't pick a 3 the first time, I would stop playing the game. So what we have to do is look at the chance of that we won. What's the chance of drawing a 3 straight up? 1 out of 4. Why? Because there's 1 3 out of 4 cards. Assuming that we won that, what's the chance of picking a 3 again? Well, this assumes we picked the 3. So if I picked the 3, I took it out and I didn't put it back in. Now, what is the chance of picking a 3? Well, there's only 3 cards left. And of those cards, how many of them are 3s? That's right. There are no 3s left. So multiply this together. 1/4 times 0 is 0. Now, all of these, I think, in this IXL ask for a percentage. So no matter what your fraction, I know this is easy, it's 0%. But what we would do is, whatever your fraction is, go second, PRB, hit equals, and then you'll get a decimal, right? Multiply it by 100, and there will be your percentage. So just to know, go further. So I'm going to clear all this. We know the answer should be 0. Stop annotating, go over here, and put in 0. Correct. All right, let's go to the next one. This time, I'm spinning the spinner twice, so I need 2 spins. What's the probability of landing on a 6 and then on a 7? So what's the chance of a 6 first, 7 second? All right, in a spinner, does the second spin really care what the first spin was? The answer is it doesn't. This is an independent setup. So what's the chance of landing on a 6? Well, I know there's 4 sections. How many 6s are there? There's 1. So that's my first probability. Because it's independent, my number's not going to change. I didn't lose any options here, right? You're not taking a piece of the spinner off and now you have 3 sections. What's the chance of a 7? Well, I have 1 out of 7, 1 out of 4. Multiply those together. Oh, this is nice. Okay, so it lets us do a fraction, so I'm good. This is 1/16. 1 out of 16. So again, I would write down your 2 things you're trying to find, 2 events you're trying to find, write your probabilities and multiply them. Okay, 1/16. So I'm going to clear that. I'm going to hit that. I'm going to go over here and put in our answer. 1/16. Terrific. Next up, dice. Remember, is this independent or dependent? That's right, it's independent. It doesn't care about the next one. So chance of a 6 and a 6. What's the probability of rolling a 6? Well, there are 6 sides, and one side has a 6 on it. Multiply that by, what's the chance of a 6? There are 6 sides. There's 1, 6 on a die. So multiply and I get 1/36. It lets me put it in as a fraction, which is nice. So 1/36 is my answer. I am looking for one more, by the way, if I can get it. I'm looking for another dependent. Awesome. Yeah, here we go. Let's see if we can get a win this time. All right, last time we got 0, like you couldn't possibly win it. So notice Now, not every card problem is going to be without putting it back, so you have to pay attention to the wording here. This is a dependent setup, so, all right, what's the chance of picking a 2 and then a number less than 3? So, probability of a 2. Well, straight up, I have 3 cards, so there's 1, 2, 1 out of 3 times. What's the chance of a number less than 3? Now, here's again what you have to remember. In order to do both of these and win, both have to happen. So if I already picked a 2, I'm now trying to win and pick a number less than 3. So because the 2 is a thing I wanted, I'm going to go over here and assume that that's what I picked. Because guess what? If you didn't pick a 2 the first time, you wouldn't keep playing. Just like last week when you needed a yellow out of the jar to win and people were picking blue. Why bother having them flip a coin, roll a die, and pick a king out of a deck? Because it doesn't matter. So we're assuming you picked a 2 the first time. So that's the 1 out of 3. All right, this part's easier. How many cards do I have left? I only have 2. Of the 2 remaining cards, how many are less than the number 3? Less than means it's lower than, so you cannot pick the 3. The only card lower than 3 is the 1. So there's 1 out of 2 cards left that work. So I would say this like idea is probably the most difficult. All right, multiply. That's 1, that's 6. So this is 1 out of 6. And yes, it does let me do a fraction. This is 1 out of 6. So let me clear this and go here and type in 1 out of 6. Submit. Keep it up. So I'm going to pause you there. I'm going to let you work through this then. Actually, I'll do this one much faster. Flip a coin twice. Probability. Heads and then heads. What's chance of heads? Heads. Coin is independent. 1/2 times 1/2 equals 1/4. Fraction or whole number? Nice. Fantastic. So pay attention. Is it independent or dependent? And if it is dependent, remember the first thing that you wanted had to have 1 in order to keep playing the game. So especially like if you have the cards, just cross off the 1, cross off whichever card they asked for at the beginning, and then look at what you have left. All right, good luck. Turn this paper in, and then you're going to pick up with this IXO, which is DD11. Good luck.